Now that we have our ability component set up, we understand gameplay attributes and we understand how to influence those through gameplay effects. Today we're going to get into gameplay abilities. Because usually the way things go is we have our attributes which are being impacted by effects, and that is generally done through gameplay abilities. It doesn't have to be, but in general that is the way this is set up to go. And a gameplay ability could be literally anything, more or less. It doesn't have to be something like an attack or a special move or whatever. It could be something like taking damage and getting knocked back. It could be something like jumping, for instance. All that kind of stuff, anything that is an action in your game, you can make into a gameplay ability. So let's just get into the basics of it today, because this is the entirety of what this plugin is all about, is being able to create gameplay abilities very easily here. And everything else we're going to be doing throughout the rest of the series is going to be centered around this. So for now, let's just get into the basics and make a blueprint of type gameplay ability. And when we scroll down here, we can see there's already a gameplay ability montage and a gameplay ability character jump, which is one of the examples that I just gave. So let's make a clean gameplay ability and call this gameplay ability, for now we'll just call it test. And when we open this blueprint up, you can see that instead of the usual begin play, begin overlap and all that kind of good stuff, we have our activate ability and our end ability. So whenever we activate an ability, of course, it's going to come through this event, and then we can do whatever we want, and at some point we have our end ability. And whenever we run this function, we end the ability. So the ability becomes non-active, and whatever we put into this event runs. So if we need to do certain things, reset certain stuff when an ability ends, we can do that through this event very easily. Now, what you usually want to do with most gameplay abilities before you do anything is we want to commit ability, is what this is called. And this tries to spend the resource that is linked to your ability, and we'll get into that in a moment, and I'll probably make a separate video on that. And if this succeeds, we get a bool out of this, whether or not the commitment really succeeded. So we can check, for instance, if we're doing a spell that costs 20 MP, it's going to try to spend that 20 MP. It's intelligent enough for itself to not go into like negative values or something like that. And if you have more than 20 MP, it will subtract that from you and give you a true value here in the bool, and you'll be able to keep on going. If you have less than 20 MP, this will return false, and we can just instantly end the ability. And you'll see that this will create a path throughout the ability where we, at multiple points, probably end up ending the ability in different ways. For now, let's just make an ability that triggers a simple attack. Next time we're going to go into this and actually make some damage dealing stuff as well, but for now we just want to trigger a simple attack. So what we can do there is we have a bunch of different options for tasks that we can do. So if we go here and we look for tasks, we have the ability tasks, and we can apply root motion with a constant force, apply root motion with a jump force. So this is just moving toward a point with a certain force. This is acting like a jump, you might think, but the character movement already has a jump. And there's two reasons that you would use this, because number one is this just applies root motion to any actor that's going to try to use this ability. So even if something doesn't have a character movement component, if it's just a normal pawn that doesn't have that component, you can still use a jump force. So we can say the distance that it should jump forward, the height that it should jump, the duration of how long that jump should last. We can give it a rotation, a certain velocity when it finishes. We can do a lot of stuff here. And this is where things become really interesting, right? Because we've got this pin up here, and this will just execute the next node right away. But because this is an asynchronous node, which you can see because it has this little clock over here, it also keeps track of these two outputs here. So when it is finished or when it is landed, those could be two different things. Oftentimes those will be the same thing. You even have a bool here, finish on landed. It will execute different stuff. So if we have an attack, for instance, that has the character jump up and then fall back down, and when it lands, it creates a shockwave, for instance. We can just apply root motion, jump force, and then on landed, we can spawn in like the particle effect for the shockwave and the collision box for that shockwave, and so on and so forth. And that's where the tasks here come in really handy. You can make your own custom tasks if you want to in C++. We won't really be delving into that too much because the tasks that Unreal gives you by default are really good as well. So let's go back again and check what other tasks we have here. So we can apply root motion with a constant force. We can apply root motion to move to an actor. We can move to a location. We can play a montage, which is an animation montage, and wait. We can repeat an action. We can spawn an actor. We can start ability states. We can wait confirm, which I believe is an input related thing. I'll make a separate video on that as well. We can delay a certain thing for an amount of time, which is just similar to the normal waiting node. But here we can also, instead of just waiting and then moving on with the rest of the code, we have two pins, one that executes immediately and one that executes when the timer finishes. So all these task nodes are really flexible to program in things like timing and different timings and different events happening simultaneously. That's what these gameplay events are really good for. For now, let's just apply root motion, constant force. So what we'll do is we'll, in the direction that we're facing at that time, is we'll apply a certain root motion force forward for a certain duration. And the way we get the world direction is by getting a reference to the actor that is doing this ability. And we've got a specific node for that, and that is get avatar actor from actor info. This just gets you a actor reference to the actor that is executing this ability. So this can be very generic, right? Because this is now a thing, an ability, that doesn't have, at least not yet, any hard references to any class whatsoever. So now this ability can be used by either the player or by an enemy. The only difference that's going to happen is eventually we'll need to play an animation montage and we'll make that into a variable, so we can set it to be whatever animation montage we want, and that way the code for this can be reused for a bunch of different types of actors. So we'll get the forward vector for the actor, and we'll say for now we'll just have to test this out a little bit. Say strength is 100 and the duration is 1. I don't know if this is a good number or not. I guess we'll figure this out at some point. Then this stop pin we can use to execute some more code immediately. So we can say for instance our play montage and wait task, which allows us to play, for instance, a dashing animation. I don't know that this character that we are using has a dashing animation. We'll look into that in a moment. And then we have this on completed, or when it starts blending out, or when it is interrupted, which is always a possibility, or when it is cancelled. We can all do different things, or we can all do the same thing here, which is end ability. So as it stands right now, this ability is just a dashing ability. And let's say when the ability ends, we want to print out a string, just so that we can see that the ability ended. If we go into the class defaults here, we can give the ability tag, and we can cancel other abilities with a certain tag when this ability activates. Or we can block other abilities from activating based on their ability tags while this ability is active. So for instance, if we're doing a dash, we don't want to be able to attack while we're dashing. We can say, for instance here, we don't have our ability tags set up at all yet, but we can add a new gameplay tag, and we can call that something like action.attack. And if we add that new attack, we can say, okay, so we don't want to be able to use action.attack based abilities while we're doing this. And then for the ability tag itself here, what we can do is we can add a subtag to actions, and we can say action.dash, adding that new tag as well. Now the engine can easily keep track of, okay, so you are dashing because you have an ability active with action.dash, and if I'm trying to do an attack, you won't let me because I'm blocking any ability with this tag in it. Then we also have the tags to do with the owner. So these are the tags to do with the abilities themselves, but we can also say, hey, as long as this ability is active, I want the owner of this ability to have a certain tag. So we can say, in this case, make an ability tag and call this status.invincible. And that means as long as we're dashing now, we will be invincible. So this is the way you can make things like a dodge roll, for instance. In much the same way as the ones above, we can also say, okay, in order to activate this ability, the owner needs to have a certain tag. So if you have like a desperation move kind of ability, which only is allowed to be used when you're under a certain amount of HP, you can give your player, or any enemy for that matter, that tag only when they are under a certain amount of HP, and then only can they use this ability. On the other side of that, we have the activation blocked tags, and that means that this cannot be used when the owner has certain tags to it. So if you have a enemy that like curses you and disallows you to use magic, for instance, if you have the status.cursed tag, which you would have to make, then you can't use this ability when that tag is on your player. Now we get into source and target, and this is because not always will you activate abilities on yourself. Sometimes you will try to activate an ability on something else. So in that case, we also have opportunities to say, hey, when the player is trying to activate an ability on an enemy, we can check either the player for having certain tags or that enemy for having certain tags, taking into account which one is the source and which one is the target. Whereas these activation ones, they don't really care about that. They just care about the thing executing the ability. So that's what all these tags are all about. It's a lot of information, as you're used to at this point. There's a lot of upfront information about this. Just wanted to show you this. These top ones are the most used ones. The further you get into the bottom here, the less useful they become, but it's good that they're there. Now, the two things that I really wanted to talk about here is down here, the gameplay effect cost. So when we added this commit ability node, I explained that it's going to try to use up some resource in your attributes, and if it is able to, this bool becomes true, and if it's not able to, this bool becomes false. It's as easy as that. This gameplay cost is the way we do that, through a gameplay effect. So we can make a gameplay effect, and we already have one, in this case, use mana, which we made last time, and use mana just takes your mana attribute and subtracts 20, as easy as that. So now that we have that gameplay effect set to that, we will try to use 20 mana, and if we can, it subtracts it for us and then does the ability. We also have a cooldown gameplay effect, and that is just a gameplay effect that will be used for, well, cooldown on an ability. So as we saw before, we have this duration policy on gameplay effects, and if we don't set that to instant, but instead to has duration, I suppose you could also use infinite for this and manually toggle it back off at some point. But for the most part, for cooldowns, you want to make a gameplay effect that has a duration, and then you can use the duration down here, the scalable float magnitude, for how long of a cooldown that ability should have. So if your ability, for instance, should only be allowed every 5 seconds, you just make a empty gameplay effect that doesn't really do anything else, that just has a duration of 5 seconds, and that's a good way to make a cooldown. For now, I'm not going to bother with that. All that said, a lot of that is side information, not relevant for what we're doing right now at the moment. Just this is probably the best moments to go over all that. We've made this dashing ability now, and with this we can't use it yet, because if I go into the gameplay, like, how should this be used? When should this be used, right? This is just a set of instructions for what the ability should do, not how it is triggered. And that is because we do that through the specific characters, whether it be through like an AI behavior tree or through your character blueprint. So let's open up our character blueprint. And here last time we had a way to like use up MP whenever we try to attack. Of course, this was just a temporary way to show you how gameplay effects and attributes work the way I showed you in this video, using the commits ability inside of a gameplay ability is the way we actually do that. So let's get rid of this for now. Here is where we start to execute the ability. So we're going to get back into this in a moment, because this is the setup that the project comes with whenever you use a Paragon character. It's got a very simple setup where it just like plays some animations, and it has a simple counter here for the attacks. We're going to just replace these with gameplay ability instead. But for now, we don't have an attack yet, we only have a dash. So let's add in just a left shift. If you're making a real game, you would have the advanced input system, and you would be mapping these to input actions rather than directly to keys. I'm not going to bother with that for now. This is not a tutorial on the advanced input system. So when we press this, we want to, with our ability system component, try and activate an ability. So we can activate an ability through a ability handle, which is not what we're going to be doing right here, right now. But we can also activate it by a tag or by class. So we gave our ability a tag, and using that tag, we can simply, if we like make literal tag container, we can say, okay, just use an ability with action.dash. And then it will look whether or not this character has access to any abilities with action.dash as a tag, and then use one of them. As far as I know, it doesn't use them randomly. It uses just the first one it finds. So it will always use the same one if it's got multiple, which is a little bit annoying. If you wanted to use a random one, you have to do a little bit more trickery. And the way you would do that, and the way I generally prefer to do it, is just try activate ability by class, because this gets you a menu of all of the ability classes that you have in your game. So let's use our gameplay ability test here, and it will just try to activate that ability. And if you want to activate a random one, you make an array with random abilities for dashing, and you just pick a random entry out of that, and that's just basic programming. When we do this, you think, okay, so now it will try to activate that ability, and we will do a dash. And you would be mistaken, because the character still doesn't have the ability, is the issue. You need to grant abilities to specific characters in order for characters to be able to execute that ability. Otherwise, every character in the game would have access to every ability you've created, and that's probably not something that you want. So what we'll do is we'll add a begin play event here, and in the ability system component, we will use the give ability node, and there we can give the ability class that we want to grant to our character. So the way I generally like to do this is to make a variable and call it something like abilities on start, and we'll make this a gameplay ability class reference. So that way, and we'll make it an array as well. So that way, if we just compile this, we can add a few different abilities here. For now, that will just be our gameplay ability test. And if we put a for each loop in there, we can just loop through however long that array is, and we don't need to go through and add more and more and more nodes every time we want to grant an ability that the character just has by default. This is just the easiest way to grant a bunch of abilities right off the bat. If you want to grant some more abilities during gameplay, like if you have an ability shop, for instance, you will have to keep track of that in some way, like in the save file, and when you reload your save file, you have another array which then grants a bunch of abilities, and a lot of that comes down to like more individualized project by project basis, how things make the most sense. Like for my game, for instance, the abilities that you have are based on your weapon. So I store simply those classes, references to those classes, on the weapons themselves. And when you switch out a weapon, it first gets rid of all the abilities that correspond to that weapon, and then it switches to the other weapon. And that weapon, whenever it gets equipped, grants all of its abilities to the player. And then when you get rid of that weapon again, it takes a look at, okay, these are all the abilities that I grant, so I'm going to take those away because you no longer have me. And then the next weapon does the same, and so on, and so on, and so on. So that's a very individualized project-on-project basis. Just figure out a good way to do that yourself. Now, abilities can have levels and they have input IDs. The levels are pretty self-explanatory. You can use these levels to impact gameplay effects and have them be more effective. So if you have a fire spell, you can say, okay, grant this spell to my character at level 3, and then the gameplay effect calculation can use that level input to multiply damage, for instance. So if you have level 1, you might do like 10 damage. If you have level 2, you might do 20 damage. Level 3 does 30 damage. That's a very linear scale. You can use that level in your calculations however you like. But now, on begin play, we're granting this ability, and then when we press left shift, we are going to try to access that ability and activate it. So let's give that a shot, finally. So we can see on the top left corner the ability is executing a few times. At some point it stops executing because I don't have enough mana anymore. It doesn't really work is the issue, and that is probably because the strength of 100 is probably just simply too low. So let's put that up to like 2500 just for testing purposes. This might be too high. Oh, there's an issue because we don't have any montages that play, so it immediately ends the ability, and when it ends the ability it also cancels any tasks that are present at the moment. So let's just take a look whether or not we have any montages that we can use for something that is a little bit like a forward dash. There's not a great animation for what I'm trying to do here, but it'll do. So we have the E ability throw. If we browse to that asset and make a montage of that, we at least have something that we can do here. So now we'll see it moves us forward and tries to do that animation. It moves us forward a lot because I set it to 2500, of course. And this is just like general gameplay programming. You're going to do a lot of troubleshooting. So let's set this to 500 instead and see what that feels like. Over a duration of 1 second, that might be a little slow. And also we don't have in the animation blueprint the slots for that animation montage. So let's add a default slot at the very end here. So we actually display the animation. If you're not familiar with animation graphs like this, I have a basic setup tutorial for like state machines. This is a little bit more complex than that. I will be making more future tutorials about those kind of things as well. Now, to make this into more of an attack, what we can also do is when we finish applying the root motion, we change the montage that we're playing. So we do that one montage in our movement, and then when that movement finishes, we play the actual attacking montage. So that will for us be the melee A montage for the time being. Again, you would probably make both of these into variables so that you can easily reuse this and make different gameplay abilities by just simply changing out the animations. So if we like promote both of these to a variable, we can say this is the dash animation and this one will be the attack animation, and we'll both of those expose them. So if we make children of this, we can just simply change those animations. So this animation will then get interrupted after this movement is done, and it will play this animation instead. Now, one thing to be aware of in this specific case is that these do not apply to the same slot. This one only does upper body animation, and the other one was in the default slot, so that might get overwritten. So in that case, what we'll also do is we just want to stop montage before we play the next. That's just a little bit of security. If you have something weird going on with like different animation slots or whatever, we just stop whatever montage we're doing before we put in the next one. And now we'll see, we'll dash and then do our attack. The dashing animation is weird because it also looks like an attacking animation, of course. So for now what we'll do is we'll just go into the dashing animation and simply clear that out so that we don't have any animation with that, because we don't have a dash animation apparently. And with that we'll see that we have half a second of dash and then he does a swing attack. So that's the basics of setting up a attacking ability, and from there we can very easily go back into our content, and now we can change the name for this to gameplay ability base attack, And here it's as easy as just making a new child blueprint class, and let's call this gameplay ability hero attack 1. And when we open that up, we get an entire event graph in which we can add some more functionality if we want to. But for the most part, what we want to do is just in the class defaults, we can now set the dashing animation to whatever we want and the attacking animation to whatever we want. And this is very easily applicable to our hero, but we can just do this same thing and just put in the animations for our villains as well. And then the same gameplay ability can be reused for multiple different characters, and they all work exactly the same anyway. They can reuse the same gameplay tags, or maybe you want to have specific gameplay tags for specific types of attacks, which you can also independently on each individual basis change here if you want to, and so on and so forth. So that is the basics of how you set up a gameplay ability. Really, really neat. The only issue is, you might be thinking, yeah, but this doesn't do anything, right? So if I use this attack against this enemy over here, it doesn't do anything. Like, I can attack him, and it looks cool, but it doesn't really do anything at all. And I don't have any, like, homing either, so it's really iffy to actually hit him with this. And he doesn't stop when I get to him and all that kind of stuff. All of that is details for now. That's all things that you can program in if you want to. Next time what we'll be doing is we'll actually be dealing with damage, because we'll be talking about gameplay events. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,